In 1837, a British military officer named Howard Vyse used gunpowder to blast his way into the Great Pyramid of Giza. He detonated charges inside the most precisely constructed building in the ancient world, cracking open chambers that had been sealed for thousands of years because he could not find any other way in. The stones were too tight, the passages were too narrow, the architecture was too perfect. And behind the stones he shattered, he found rooms that were not supposed to exist. Empty rooms. Rooms with no decoration, no treasure, no sarcophagus, no obvious purpose. Rooms that seemed to have been sealed at the time of construction and never entered again. Rooms that raised a question that has never been satisfactorily answered. Why would the builders of the most ambitious construction project in ancient history go to extraordinary lengths to create spaces deep within the structure that they then sealed permanently and completely, with no apparent intention that anyone should ever enter them? That question still stands, and it has grown larger with time, not smaller, because in the 2 centuries since Vyse's crude explosions, a succession of increasingly sophisticated technologies has been aimed at the Great Pyramid. Acoustic surveys, microgravity measurements, infrared thermography, cosmic ray muon tomography, and what these technologies have revealed, layer by layer, scan by scan, is that the pyramid we thought we understood contains far more empty space than anyone suspected. There are voids behind the walls of the Grand Gallery. There are anomalies above the king's chamber. There are density variations in the body of the pyramid that suggest the existence of passages, chambers, or cavities that no human eye has seen since the day the last stone was laid in place, roughly 4,500 years ago, according to mainstream Egyptology. The Great Pyramid is not solid. It never was. It is a structure of extraordinary complexity, containing known passages and chambers that represent only a fraction of its internal architecture. And the unknown portions, the hidden spaces, the sealed voids, the chambers that instruments can detect but hands cannot reach, may contain answers to questions that have haunted Egyptology for generations. What was the true purpose of the pyramid? Why does it contain 3 known chambers at different levels when every other pyramid has 1 or 2? What happened to the original contents of the king's chamber sarcophagus, which was found empty? And what lies behind the small square doors at the ends of the narrow shafts that extend from the queen's chamber into the body of the pyramid, doors that were discovered in 1993 and that have never been fully opened? Every century adds a new layer of investigation. Every decade brings a new technology, and every technology reveals the same uncomfortable truth. The pyramid is more complex than we thought. Its interior is more layered, more structured, more deliberately designed than any model has been able to accommodate. The builders did not simply stack blocks to make a pyramid shape and carve a few rooms inside. They created an interior world, a labyrinth of passages and spaces and sealed chambers, some visible and some hidden, some accessible and some permanently sealed, and they did so with a level of planning and precision that suggests every void, every gap, every concealed space was deliberate. The Great Pyramid of Giza is the last surviving wonder of the ancient world. It stood as the tallest structure on Earth for nearly 4,000 years. It contains an estimated 2.3 million blocks of limestone and granite, with a total mass of roughly 6 million tons. Its base covers an area of approximately 5.3 hectares. Its original height was approximately 146.6 meters, reduced by the loss of its apex and its smooth outer casing stones, to roughly 138 meters today. It is oriented to the cardinal directions with an accuracy that modern surveyors find difficult to match. And after more than 200 years of modern exploration, it is still giving up secrets. There is a disquieting quality to this. A building that we have studied so intensely for so long should by now have yielded all of its secrets. We should know everything about it. We should have mapped every passage, entered every chamber, measured every block. But we have not. The technologies of the 21st century, technologies that can peer through solid rock and count the arrivals of subatomic particles from the edge of the atmosphere, have revealed that the interior of the Great Pyramid is not what we thought it was. It is more complex, more layered, more mysterious, And the more we learn, the more we realize how much remains unknown. The pyramid is not giving up its secrets willingly. It is giving them up reluctantly, grudgingly, one anomaly at a time, each answer raising 3 new questions that are harder to resolve than the last. By the end of tonight, you are going to understand what has been found inside the Great Pyramid, what is suspected to be inside but has not yet been reached, and why the hidden chambers matter so much. You are going to learn about the technologies that have been used to peer inside the pyramid without opening it, and what those technologies have revealed. You are going to follow the trail of discoveries from Weiss's gunpowder to the latest muon scans, and you are going to confront the possibility that the most studied building on Earth still contains rooms that no one has entered for nearly 5 millennia. Rooms that may hold objects, inscriptions, or architectural features that could transform our understanding of ancient Egypt. Before we get started, if you find these mysteries as fascinating as we do, take a second to like the video or subscribe. It is a simple action, but it helps this channel reach more curious minds like yours. Now let's begin. To understand why hidden chambers in the Great Pyramid matter, we first need to understand what we already know about the pyramid's interior. Because the known chambers are themselves extraordinary, and they provide the context against which the hidden spaces must be evaluated. The Great Pyramid, known to the ancient Egyptians as Akhet Khufu, meaning horizon of Khufu, was built during the reign of the pharaoh Khufu, the second king of the 4th dynasty. His reign is conventionally dated to approximately 2589 to 2566 before the Common Era, a span of roughly 23 years. The pyramid was his funerary monument, the centerpiece of a royal necropolis that also included 3 small queen's pyramids, a mortuary temple, a valley temple connected by a causeway, boat pits containing full-sized wooden boats, and an extensive cemetery of mastaba tombs for members of the royal court. The pyramid's exterior is familiar to everyone. The 4 triangular faces rising from a square base to a point. The courses of limestone blocks, each course slightly smaller than the one below, creating the stepped profile that is now visible after the loss of the smooth outer casing. The entrance on the north face, positioned roughly 17 meters above ground level. The mass, the scale, sheer physical presence of a structure that took millions of tons of stone and, according to the Greek historian Herodotus, writing more than 2,000 years after the fact, the labor of 100,000 men working in 3-month shifts over a period of 20 years. But the exterior is only the beginning. The interior of the Great Pyramid contains a system of passages and chambers that is unlike anything found in any other Egyptian pyramid. And it is this internal architecture, its complexity, its anomalies, and its unexplained features that has made the Great Pyramid the focus of so much investigation and so much speculation. The known internal features can be described as follows. The original entrance is located on the north face, approximately 17 meters above the base, slightly east of center. From this entrance, a descending passage slopes downward at an angle of roughly 26 degrees through the body of the pyramid and into the bedrock beneath it, extending for a total distance of approximately 105 meters before leveling out and terminating in a rough, apparently unfinished chamber cut into the bedrock. This is the subterranean chamber, also called the pit. It is a large, irregularly shaped room, roughly 14 meters long, 8 meters wide, and about 3.5 meters high, with a rough, uneven floor and a mysterious blind passage extending from its south wall for a distance of about 16 meters before ending abruptly. The subterranean chamber appears to be unfinished. Its walls and floor are rough-hewn, not smoothed or polished like the other chambers. This has led many scholars to conclude that it represents an abandoned first plan for the burial chamber, superseded by a decision to build the burial chamber higher up within the body of the pyramid itself. Approximately 28 meters from the original entrance, the descending passage is intersected by an ascending passage and narrow corridor that climbs upward at roughly the same angle as the descending passage, but in the opposite direction. The junction between the 2 passages was originally concealed by a large limestone block, fitted so perfectly into the ceiling of the descending passage that it was invisible from below. This concealment was so effective that the ascending passage remained unknown until the 9th century of the Common Era, when the Abbasid Caliph al-Mamun, seeking treasure within the pyramid, ordered his workers to tunnel into the structure from the north face. Al-Mamun's tunnel, which can still be entered today, bypassed the concealing block and broke into the ascending passage from the side, revealing the upper chambers for the first time in recorded history. Though there is some debate about whether the pyramid had been entered and resealed in antiquity. The ascending passage climbs for approximately 39 meters before opening into one of the most remarkable architectural spaces in the ancient world. The Grand Gallery. This is a corbelled corridor, roughly 47 meters long, 8.5 meters high, and slightly over 2 meters wide at the base, narrowing to approximately 1 meter at the ceiling through 7 courses of corbelled limestone blocks, each course projecting inward by about 7.5 centimeters. The Grand Gallery is an extraordinary feat of engineering. Its walls are composed of massive, precisely dressed limestone blocks, fitted together with such accuracy that, even after 4.5 millennia, a knife blade cannot be inserted between them in most places. The floor of the Grand Gallery has a central channel, flanked by raised stone benches on each side, with regularly spaced slots cut into the benches. The purpose of these slots is debated. Some scholars believe they held wooden beams that supported the granite plugs used to seal the ascending passage after the burial. Others have proposed more speculative functions. At the base of the Grand Gallery, a horizontal passage leads to the Queen's Chamber. Despite its name, the Queen's Chamber has nothing to do with any queen. The name was given by early Arab explorers who assumed, incorrectly, that the smaller of 2 burial chambers would belong to the Queen. The Queen's Chamber is a roughly rectangular room, approximately 5.75 meters long, 5.23 meters wide, and 6.26 meters high, with a pointed, gabled ceiling formed by 2 massive limestone slabs leaning against each other. The chamber contains a niche in its east wall, roughly 4.5 meters high and 1.5 meters wide at the base, narrowing to about 0.5 meter at the top. The purpose of this niche is unknown. Some scholars believe it once held a statue of the king. Others believe it may have served a structural or ritual function. The chamber also contains the entrances to 2 narrow shafts, each roughly 20 centimeters square, that extend upward into the body of the pyramid from the north and south walls. These shafts, often called air shafts, are among the most enigmatic features of the Great Pyramid, and we will return to them in detail later. At the top of the Grand Gallery, a low passage leads through an antechamber, which originally contained a system of 3 portcullis slabs, large flat slabs of granite that could be lowered vertically to seal the passage into the King's Chamber. The King's Chamber is the only room in the pyramid constructed entirely of granite. It measures approximately 10.47 meters long, 5.23 meters wide, and 5.82 meters high. Its walls are composed of massive blocks of red granite from the quarries at Aswan, more than 800 kilometers to the south. The ceiling consists of 9 granite beams, each weighing between 25 and 80 tons, spanning the full width of the chamber. Above these beams, there are 5 additional relieving chambers, stacked one above the other, designed to distribute the enormous weight of the pyramid above the King's Chamber and prevent the ceiling from collapsing. The uppermost of these relieving chambers has a pointed roof formed by 2 massive limestone slabs leaning against each other, echoing the gabled ceiling of the Queen's Chamber. The King's Chamber contains a single object, a rectangular granite sarcophagus, approximately 2.28 meters long, 0.98 meters wide, and 1.05 meters deep, cut from a single block of red Aswan granite. The sarcophagus is undecorated. It bears no inscriptions, no cartouches, no images of any kind. It was found empty. Its lid, if it ever had one, is missing. The sarcophagus is slightly wider than the ascending passage, which means it could not have been brought up through the passage after construction. It must have been placed in the chamber during construction, before the passages were completed. This fact confirms that the King's Chamber was planned from the beginning, not added as an afterthought. Above the King's Chamber, the 5 relieving chambers are stacked in a column that extends roughly 17 meters upward into the body of the pyramid. The lowest 4 have flat granite beam ceilings and floors. The uppermost has the pointed limestone gable. These chambers were not accessible from the king's chamber through any known passage at the time of construction. They were discovered by Weiss and his associate J.R. Hill in 1837, who noticed a crack in the ceiling of the first relieving chamber, called Davison's Chamber, after the British consul Nathaniel Davison, who had discovered it in 1765. Weiss suspected there were more chambers above. Unable to find a way in, he ordered his workers to blast upward with gunpowder. The explosions broke through the granite and limestone, revealing 4 previously unknown chambers. Weiss named them after individuals associated with his expedition and with British interests in Egypt: Wellington's Chamber, Nelson's Chamber, Lady Arbuthnot's Chamber, and Campbell's Chamber. In 3 of these relieving chambers, Weiss found something remarkable: red-painted quarry marks on the rough, unfinished surfaces of the limestone blocks. Among these marks were several instances of the cartouche of Khufu, spelled in hieroglyphs as Koch WFW, along with gang names, the identifying labels of the work crews who had quarried and transported the blocks. These were the only inscriptions bearing Khufu's name found anywhere in the pyramid, and they provide the primary direct evidence linking the Great Pyramid to the pharaoh Khufu. Their authenticity has been questioned by some critics, who have suggested that Weiss may have forged the marks to enhance his discovery, but most Egyptologists accept them as genuine, noting that the marks include hieroglyphic forms and spelling conventions consistent with the 4th dynasty, and that some of them are partially hidden behind adjacent blocks, meaning they must have been painted before the blocks were placed, not after. The relieving chambers themselves are a testament to the builder's engineering sophistication. They were designed to protect the king's chamber from the crushing weight of the pyramid above, which at that level amounts to tens of thousands of tons of stone. The granite beams that form the ceiling of the king's chamber, despite being among the largest single stones in the entire pyramid, would not have been strong enough on their own to support this weight. The relieving chambers distribute the load gradually, transferring it from the flat beams of the lowest chamber through the successively higher chambers to the pointed gable of the uppermost chamber, which deflects the weight outward to the surrounding masonry. The system is elegant, effective, and completely invisible from the king's chamber itself. It is hidden engineering, structural intelligence concealed behind the smooth granite ceiling that the occupant of the chamber would have seen above. This combination of visible perfection and hidden complexity is a recurring theme in the Great Pyramid. The surfaces that were meant to be seen, the polished granite of the king's chamber, the smooth limestone of the passage walls, the precise coursing of the exterior blocks, are finished to extraordinary standards. The surfaces that were never meant to be seen, the rough stone behind the relieving chambers, the quarry marks painted hastily on blocks that would be hidden for eternity, the crude filling between courses of masonry are workmanlike but unfinished. The pyramid has 2 faces, a public face of perfection and a private face of rough functionality. And the question that haunts every investigation is simple: how much of the private face have we seen? How much remains hidden behind the public face? The history of exploration inside the Great Pyramid is itself a study in the relationship between ambition and limitation. From Al-Mamun in the 9th century to Weiss in the 19th, from the careful surveys of the British archaeologist Flinders Petrie in the 1880s to the robotic probes of the 21st century, each generation has brought new tools and new expectations. Petrie's survey, conducted between 1880 and 1882, remains one of the most detailed measurements of the pyramid ever undertaken. Using simple instruments, a theodolite, a steel tape, and meticulous patience, Petrie measured the pyramid's dimensions with an accuracy that was not significantly improved upon for more than a century. His measurements revealed the extraordinary precision of the pyramid's construction and established the baseline against which all subsequent surveys have been compared. Petrie was also the first to notice certain peculiarities of the internal architecture that would later fuel speculation about hidden chambers. he observed that the joints between the granite blocks in the king's chamber showed signs of having shifted, suggesting that the chamber had experienced structural stress at some point in its history. He noted cracks in the granite beams of the ceiling, cracks that had been filled with gypsum plaster, possibly in antiquity. These repairs suggested that the king's chamber had been damaged, perhaps by an earthquake, and subsequently repaired, raising questions about the structural integrity of the pyramid's upper regions and the possibility that the damage had altered or concealed features of the original architecture. Now let us step back and consider the scale of what we are looking at. The Great Pyramid has a total volume of approximately 2.6 million cubic meters. The known internal passages and chambers, including the descending passage, the ascending passage, the Grand Gallery, the subterranean chamber, the Queen's Chamber, the King's Chamber, and the 5 relieving chambers, together occupy a tiny fraction of this total volume. The exact figure is difficult to calculate precisely because the passages are irregular in cross-section and the chambers vary in shape, but estimates suggest that the known internal spaces account for less than 1% of the pyramid's total volume. Less than 1%. The remaining 99+% is, so far as we know, solid stone. Or is it? That question, which seems simple, turns out to be extraordinarily difficult to answer, because we cannot see inside the pyramid, we cannot X-ray it, we cannot cut it open, and until recently, we had no reliable way to determine whether the vast mass of stone between the known chambers contained additional voids, passages, or spaces that were sealed at the time of construction and have never been detected. The pyramid's builders were demonstrably capable of creating hidden spaces. The ascending passage was concealed so effectively that it remained unknown for thousands of years. The relieving chambers above the king's chamber were completely inaccessible until Vyse blasted his way in. If the builders could hide the ascending passage and the relieving chambers, what else could they have hidden? To understand the full scope of this question, consider the engineering capabilities that the pyramid demonstrates. The precision of the king's chamber alone is remarkable. The granite blocks that form its walls are fitted together with tolerances measured in fractions of a millimeter. The 9 ceiling beams, each weighing between 25 and 80 tons, were quarried at Aswan, transported more than 800 kilometers up the Nile, hauled across the desert to the construction site, lifted to a height equivalent to a modern 15-story building, and positioned with such accuracy that the ceiling is level to within approximately 1 centimeter. The engineering required to achieve this precision, using only the tools and techniques available in the 3rd millennium before the Common Era, is staggering. Copper chisels, stone hammers, wooden sledges, ramps, levers, and human muscle. No iron, no steel, no wheels on the construction site, no pulleys, so far as we know, and yet the result is a structure that modern engineers regard with a mixture of admiration and bewilderment. The precision extends to the smallest details. The descending passage, which runs in a straight line for over 100 meters through the body of the pyramid and into the bedrock beneath, deviates from a true straight line by less than half a centimeter over its entire length. The 4 sides of the base are equal in length to within approximately 5 centimeters over a distance of 230 meters. The right angles at the 4 corners are accurate to within a few arc seconds, a level of precision that approaches the limits of modern surveying equipment. These are not the tolerances of rough-hewn stonework. These are the tolerances of precision engineering, achieved by people whose methods we do not fully understand. This level of precision implies a level of planning that is equally impressive. The pyramid's internal architecture, with its multiple passages, chambers, and structural features at different levels, must have been planned in detail before construction began. Changes to the internal layout during construction would have been extremely difficult, if not impossible, because the passages and chambers had to be built into the structure as it rose, course by course, block by block. The walls of the king's chamber, for example, had to be in place before the courses of limestone that surrounded them were laid. The granite beams of the ceiling had to be positioned before the relieving chambers above them were constructed. The Grand Gallery had to be built as the pyramid rose around it, each course of corbelled blocks projecting slightly further inward than the course below. Any mistake, any miscalculation, would have been extraordinarily difficult to correct. This implies that the builders had a detailed plan of the pyramid's interior before the first block was laid. They knew where every passage would go, where every chamber would be, where every structural feature would be located, and they had the ability to execute that plan with extraordinary precision over a construction period that may have lasted 20 years or more. The question is, does the plan we know about, the plan represented by the known passages and chambers, represent the entire plan? Or was there more? The numbers are striking. Consider the sheer mass of stone involved. 2.3 million blocks, 6 million tons, a base covering more than 13 acres, a height equivalent to a modern 48-story building. Within this colossal mass, the known internal spaces are like a few tiny bubbles in a vast block of ice. There is room, in terms of sheer volume, for dozens of additional chambers of the size of the king's chamber, without significantly affecting the structural integrity of the pyramid, and the builders had both the skill and the motivation to create hidden spaces. They demonstrated the skill by building the concealed ascending passage and the inaccessible relieving chambers. They demonstrated the motivation by filling those spaces with structural features, the granite plugs, the portcullis system, the granite beams that served no purpose other than to seal and protect the interior. Why go to such lengths to seal and protect spaces that, in the conventional interpretation, serve no function beyond holding the dead body of a single king? The standard Egyptological answer is that the pyramid was a tomb and nothing more. The chambers held the king's body and his grave goods. The passages provided access for the funeral procession and were then sealed. The sarcophagus contained the mummified remains of Khufu, and the hidden spaces, the relieving chambers, and the concealed passages served purely structural and security functions, protecting the burial and deterring tomb robbers. This explanation is plausible. It is consistent with the known function of other royal tombs in Egypt, and it may be entirely correct, but it does not explain everything. It does not explain why the Great Pyramid has 3 chambers at 3 different levels, connected by a complex system of passages, when no other pyramid in Egypt has anything remotely comparable. The 5th dynasty pyramid of Unas, for example, has a single burial chamber and a single antechamber, connected by a single passage. The 6th dynasty pyramid of Pepi II has a similar simple layout. Even Khufu's own father, Sneferu, who built 3 pyramids, used relatively simple internal arrangements. The Great Pyramid's internal complexity is unique, and uniqueness demands explanation. It does not explain the purpose of the so-called air shafts in the Queen's chamber, which do not reach the outer surface of the pyramid and which were originally sealed at both ends, meaning they could not have served as ventilation channels. It does not explain why the Queen's chamber was left with a rough, unfinished floor and an enigmatic niche in its east wall. It does not explain why the subterranean chamber was apparently abandoned in an unfinished state, with a mysterious blind passage extending from its south wall into the bedrock. It does not explain why the Queen's chamber shafts, unlike the shafts in the King's chamber, which do reach the outer surface, were sealed at both ends and never completed as through passages. The shafts in the King's chamber are themselves enigmatic. The northern shaft points roughly toward the celestial North Pole, as it would have appeared in the 3rd millennium before the Common Era. The southern shaft points roughly toward the constellation of Orion's belt. These alignments have led some researchers, notably Robert Bauval, to propose that the shafts served an astronomical or ritual function, symbolically connecting the king's burial chamber with specific stars associated with the afterlife. If this interpretation is correct, the shafts were not ventilation channels, but spiritual conduits, designed to facilitate the king's journey to the stars. And if the king's chamber shafts served a spiritual function, what about the queen's chamber shafts, which are similar in size and orientation, but sealed at both ends? Were they spiritual conduits that were sealed before completion? Were they part of an abandoned plan? Or were they sealed deliberately, for reasons we do not yet understand? And it does not explain the results of the latest technological investigations, which have detected previously unknown voids within the pyramid's body. voids that do not correspond to any known architectural feature, and whose purpose, size, and contents remain completely unknown. What scientists discovered next was worse than anyone expected, not because it threatened the conventional interpretation, though it did, but because it revealed how little we actually know about the internal structure of the most famous building on Earth. The story of hidden chambers in the Great Pyramid begins, properly speaking, not in the modern era, but in the 9th century of the Common Era, when the Abbasid Caliph Al-Ma'mun arrived at Giza with a workforce of stonemasons, engineers, and labourers, determined to find what lay inside the ancient structure. Al-Ma'mun, who reigned from 813 to 833, was a patron of learning and science, who had founded the House of Wisdom in Baghdad, one of the greatest centres of scholarship in the medieval world. He was drawn to the Great Pyramid by legends that it contained vast treasures, astronomical instruments, and maps of the heavens. Unable to find the concealed original entrance, he ordered his workers to force their way in through the north face, carving a tunnel into the limestone with hammers, chisels, and fire. The process was brutal and slow. The limestone blocks were enormous and tightly fitted. The workers heated the stone with fires and then doused it with cold vinegar, causing it to crack, then chipped away the fragments with iron tools. After tunneling roughly 27 meters into the pyramid, Al-Ma'mun's workers heard the sound of a heavy stone falling somewhere ahead of them. They changed direction toward the sound and broke into the descending passage. They had dislodged a limestone ceiling block that concealed the entrance to the ascending passage. Following the ascending passage upward, they discovered the Grand Gallery, the Queen's Chamber, and eventually the King's Chamber with its empty granite sarcophagus. According to medieval Arab historians, Al-Ma'mun found the pyramid empty. No treasure, no mummy, no grave goods. Nothing but bare stone and silence. This emptiness has posed a problem for Egyptologists ever since. If the Great Pyramid was built as a tomb for Khufu, where is Khufu? Where is his mummy? Where are the grave goods, the furniture, the jars of food and wine, the jewellery, the weapons, the religious texts, the personal objects that were routinely placed in Egyptian royal burials? Every other intact royal burial that has been discovered in Egypt, most famously the tomb of Tutankhamun in the Valley of the Kings, contained thousands of objects. The tomb of Hetephes, Khufu's own mother, discovered in a shaft tomb near the Great Pyramid in 1925 by the American archaeologist George Reisner, contained a rich assemblage of furniture, gold, canopic jars, and other grave goods, though her sarcophagus too was found empty. If Khufu's burial was even remotely comparable to his mother's, the king's chamber should have been filled with objects of extraordinary value and historical significance. The standard explanation is that the pyramid was robbed in antiquity. Tomb robbery was endemic in ancient Egypt, and virtually every royal tomb that has been investigated shows evidence of ancient looting. The granite plugs that sealed the ascending passage were bypassed, either by the robbers who first entered the pyramid or by later intruders, and the contents of the chambers were removed. This explanation is consistent with the general pattern of tomb robbery in Egypt, and it may well be correct. But it leaves questions. If the robbers entered through the passage system, they would have needed to bypass not only the granite plugs, but also the portcullis system in the antechamber to the king's chamber. Both of these barriers would have required considerable effort and time to overcome. Were the robbers so thorough that they removed every single object, including the mummy, without leaving any trace of their passage? Were they so efficient that they left no scraps, no fragments, no overlooked items in the corners of the chambers? The tomb of Tutankhamun, which was robbed at least twice in antiquity, still contained thousands of objects. The robbers of the Great Pyramid, if there were robbers, left nothing at all. There are further peculiarities about the sarcophagus that deepen the mystery. The granite box in the king's chamber is slightly too wide to have been transported through the ascending passage after the pyramid was built. This means it was placed in the chamber during construction, before the passages were completed, confirming that the king's chamber and its sarcophagus were part of the original plan. But the sarcophagus shows signs of rough workmanship that contrast sharply with the extraordinary precision of the rest of the chamber. Its surfaces are not polished to the mirror finish seen on other royal sarcophagi. Its corners show what appear to be saw marks that were not fully dressed, and there are no inscriptions, no cartouches, no decorative elements of any kind on its surface or interior. For the sarcophagus of one of the most powerful kings in Egyptian history, this simplicity is striking. It has led some researchers to question whether the granite box was ever intended as the final resting place for Khufu's body, or whether it served some other function, perhaps a ritual purpose, while the actual burial was placed elsewhere. The theory that the Great Pyramid underwent one or more major design changes during construction has become widely, though not universally, accepted among Egyptologists. The standard version of this theory, first proposed by the German Egyptologist Ludwig Borchardt in the early 20th century and later refined by others, suggests that the pyramid was built in 3 phases, each with a different plan for the location of the burial chamber. In the first phase, the burial was to be in the subterranean chamber, a room carved into the bedrock beneath the pyramid's foundation. For reasons that are unclear, this plan was abandoned before the chamber was completed, and a new burial chamber was planned higher up, within the body of the pyramid. This second chamber is identified with what we now call the Queen's Chamber. But this plan too was apparently abandoned, and the burial chamber was moved even higher, to the location we now call the King's Chamber. The Grand Gallery and the system of portcullis slabs and granite plugs were added as part of this third and final phase. This 3-phase theory is elegant and explains many of the anomalies in the pyramid's internal architecture. It explains the existence of 3 chambers at 3 different levels. It explains why the subterranean chamber appears unfinished. It explains the apparent simplicity of the Queen's Chamber, which lacks the granite construction and portcullis system of the King's Chamber. And it is consistent with what we know about the evolution of pyramid design during the 4th dynasty, when architects were experimenting with different internal layouts and making changes during construction, as seen most dramatically in the bent pyramid of Sneferu, where the angle of the exterior slope was changed midway through construction. But here is the problem. The 3-phase theory assumes that each design change was a correction, a movement from an inferior plan to a superior one. It assumes that the subterranean chamber was abandoned because the builders decided that a chamber in the bedrock was insufficient and a chamber within the pyramid body would be better. It assumes that the Queen's Chamber was abandoned because the builders decided to place the burial even higher. But there is no evidence for these assumptions beyond the apparent unfinished state of the lower chambers. What if the design changes were not corrections but additions? What if the builders always intended to create multiple chambers at multiple levels, each serving a different function? What if the subterranean chamber, the Queen's Chamber, and the King's Chamber were all part of the original plan, each serving a specific purpose within a complex ritual program that we do not yet understand? And what if there were additional chambers, beyond the 3 we know about, that were also part of the original plan? Chambers that were sealed at the time of construction and have never been found. There is another possibility, one that has been whispered about in Egyptological circles for decades, but rarely stated openly. The possibility that the King's Chamber was never the primary burial chamber, that the real burial, the actual tomb of Khufu with his grave goods and his mummy, is elsewhere in the pyramid, in a chamber that has never been found. A hidden chamber, a sealed room inaccessible from the known system, containing the undisturbed burial of one of the most powerful kings of the ancient world. This possibility is not as wild as it might sound. The Great Pyramid's internal architecture shows clear evidence of multiple design phases, with chambers at 3 different levels that may represent 3 successive plans for the burial location. The subterranean chamber, carved into the bedrock beneath the pyramid, appears to represent the first plan, abandoned before completion. The Queen's Chamber, located within the body of the pyramid, but below the midpoint, may represent the second plan, also apparently abandoned. The King's Chamber, located higher still, appears to represent the third and final plan. But what if there was a 4th plan? What if, after constructing the King's Chamber as a decoy or a cenotaph, the builders created a final, truly secret chamber elsewhere in the pyramid one that was never connected to the known passage system and that has remained sealed and hidden for nearly 5 millennia. The idea is not without precedent. Ancient Egyptian funerary architecture frequently employed deception and misdirection to protect royal burials from tomb robbers. False passages, blocked corridors, concealed entrances, and dummy chambers are found in tombs throughout Egypt. The tomb of Seti I in the Valley of the Kings, for example, contains a mysterious descending passage beyond the burial chamber that has never been fully explored and whose purpose is unknown. The tomb of Senusret III at Dahshur contains an elaborate system of passages and chambers designed to confuse anyone who entered without knowledge of the layout. The Great Pyramid's own concealed ascending passage demonstrates that the builders were willing and able to create hidden passages that could evade detection for millennia. There is a further oddity about the Queen's Chamber that supports the idea of hidden spaces beyond the known architecture. The Queen's Chamber was discovered in a state that does not fit neatly into any conventional explanation. Its floor was rough and unfinished. Unlike the polished granite floor of the King's Chamber, its walls were plain limestone, undecorated and uninscribed. Its niche, cut into the east wall, was empty and purposeless, or at least purposeless within any framework we currently understand. And most enigmatically, the entrances to the two small shafts in the north and south walls were originally concealed behind a thin layer of limestone. The shafts did not open into the chamber. They were sealed behind the surface of the wall, invisible from inside the room. They were discovered only when the British engineer Wayneman Dixon, in 1872, noticed a crack in the south wall and probed it with a wire. The wire passed through the wall and into an open space beyond. Dixon cut through the thin limestone layer and discovered the shaft entrance. He then found a matching shaft entrance on the north wall by measurement and symmetry. This concealment is extremely significant. The builders deliberately sealed the shaft entrances behind the wall surface. They did not want anyone inside the Queen's Chamber to know the shafts were there. Why? If the shafts were ventilation channels, why hide them? If they were symbolic passages for the king's spirit, why seal them behind a layer of stone that would need to be broken to access them? The concealment makes sense only if the shafts were not intended to be seen or used from within the Queen's Chamber. They were hidden features of a hidden architecture, designed to be invisible to anyone who entered the known passage system. Dixon's exploration of the shafts in 1872 yielded another tantalizing discovery. Inside the northern shaft, near its entrance in the Queen's Chamber wall, Dixon found a small collection of objects. A rough stone ball, approximately the size of a cricket ball, a small bronze hook or grappling tool, and a piece of cedar wood, thin and fragile, that appeared to be a measuring rod or ceremonial wand. These objects, known as the Dixon relics, were removed from the shaft and eventually dispersed. The stone ball and the bronze hook ended up in the British Museum. The cedar wood fragment was lost for more than a century, finally rediscovered in a cigar box at the University of Aberdeen in 2020. Radiocarbon dating of the cedar wood fragment placed it in the range of 3,341 to 3,094 before the Common Era, somewhat earlier than the conventional date for Khufu's reign, though within the margin of error for Old Kingdom radiocarbon dates. The Dixon relics raise more questions than they answer. What were these objects doing inside a shaft in the Queen's Chamber? Were they deliberately placed there during construction as ritual offerings or foundation deposits? Were they tools accidentally left behind by the workers who built the shaft? Or were they placed there at a later date, introduced through the shaft entrance by someone who entered the chamber before Al-Mansur's forestry? And it gets worse, because the question of hidden chambers is not merely a matter of speculation. It is supported by physical evidence from multiple independent investigations conducted over the past 4 decades, each using a different technology, each detecting anomalies within the pyramid structure that cannot be explained by the known internal architecture. The first major investigation was conducted in 1968 and 1969 by a team led by the American physicist Luis Alvarez, a Nobel laureate in physics. Alvarez proposed using cosmic ray muons to image the interior of the second pyramid of Khafre. which was thought to have a simpler internal structure than the Great Pyramid. Muons are subatomic particles produced when cosmic rays from space strike atoms in the upper atmosphere. They rain down on the Earth's surface continuously, passing through solid matter like ghostly bullets, but losing energy and being absorbed at a rate that depends on the density and thickness of the material they traverse. By placing muon detectors beneath a large structure and measuring the rate and direction of muon arrivals, scientists can create a density map of the structure above, revealing areas of higher density, solid stone, and areas of lower density, voids or chambers. Alvarez's team placed muon detectors in the existing chamber beneath the second pyramid and recorded muon arrival patterns over a period of several months. The results showed no evidence of hidden chambers of significant size within the portion of the pyramid surveyed by the detectors. But the technique was limited by the technology of the time. The detectors were large and cumbersome, the data collection was slow, and the resolution was modest. The absence of a detection was not proof that hidden chambers did not exist, only that the equipment had not detected any within its limited field of view and at the resolution available. The concept lay dormant for decades, but it did not die. In 1986, a French team led by the architects Gilles Dormion and Jean-Patrice Goydin conducted a different kind of investigation. Using microgravity measurements, a technique that detects tiny variations in the local gravitational field caused by differences in the density of the underlying material, they surveyed the corridor leading to the Queen's chamber. Microgravity is exquisitely sensitive. A void within a solid structure, even a relatively small one, will produce a measurable reduction in the gravitational pull at the surface above or beside it, because the void contains air rather than stone, and air is far less dense. By mapping the gravitational field point by point along the corridor, Dormion and Goydin could search for anomalies that might indicate the presence of hidden spaces. They found anomalies, 3 of them. In the corridor leading to the Queen's chamber, their microgravity measurements indicated areas of reduced density in the walls, consistent with the presence of voids or cavities behind the limestone blocks. The anomalies were not large enough to represent full-scale chambers, but they were significant enough to suggest that there were spaces behind the walls that were not part of the known internal architecture. In response to these findings, the Egyptian authorities permitted a limited drilling investigation. Small boreholes were drilled into the corridor walls at the locations of the microgravity anomalies. In at least one case, the drill broke through into an open space behind the wall, a cavity filled with fine sand. The discovery confirmed that the walls of the corridor concealed spaces that were not visible from the passage itself. But the investigation was halted before the cavities could be fully explored, and the boreholes were sealed. The nature, extent, and purpose of the spaces behind the walls remain unknown. In 1993, an event occurred that captured the imagination of the public and the attention of the academic world in equal measure. The German engineer Rudolf Gantenbrink, working under a contract with the German Archaeological Institute in Cairo, sent a small robot named Up-Uaut-2, an Egyptian word meaning opener of the ways, into the southern shaft of the Queen's chamber. The shaft is approximately 20 centimeters square, far too small for a human to enter. It extends upward from the south wall of the Queen's chamber at an angle of approximately 39.6 degrees, climbing through the body of the pyramid for a distance of roughly 65 meters before encountering an obstacle. Gantenbrink's robot, equipped with a camera, lights, and a laser alignment system, crawled up the shaft on treads and transmitted video back to the surface. What it showed at the end of the shaft was startling. A small limestone block, fitted into the shaft like a door, with 2 corroded copper fittings, later described as handles or pins, attached to its surface. The discovery was electrifying. Here was a sealed barrier deep within the Great Pyramid, blocking a shaft that extended from the Queen's chamber toward the southern face of the pyramid. What was behind it? Was it a door that could be opened? Did it conceal a passage, a chamber, a void of some kind? Or was it simply a structural feature, a blocking stone with no further significance? Gantenbrink was not permitted to investigate further. His contract with the German Archaeological Institute was not renewed, and the Egyptian authorities restricted access to the shafts. The discovery became mired in controversy, with disputes over media rights, academic credit, and the authority to conduct further investigations. For nearly a decade, the blocking stone at the end of the Southern Queen's Chamber shaft remained unexplored. In 2002, the National Geographic Society, in collaboration with the Egyptian Supreme Council of Antiquities, sponsored a new robotic investigation. A robot called Pyramid Rover was sent up the southern shaft to the blocking stone. Under the direction of Zahi Hawass, then Secretary General of the Supreme Council of Antiquities, the robot drilled a small hole through the blocking stone and inserted a camera on the other side. The live broadcast was watched by millions of viewers around the world. What the camera showed was not a treasure chamber. It showed a small, rough-walled space, about 18 centimeters deep, terminated by another stone. A second blocking stone. Behind the first door, there was not a room, but another barrier. The result was simultaneously disappointing and tantalizing. Disappointing because there was no dramatic revelation, no hidden chamber filled with gold and papyri. Tantalizing because the presence of a second blocking stone implied that there was something further beyond, something that the builders had gone to considerable lengths to conceal behind not one but two barriers in a shaft only 20 centimeters wide. The northern shaft of the Queen's Chamber was also explored during this investigation. It too was found to terminate in a blocking stone, similar to the one in the southern shaft. The symmetry suggested a deliberate architectural feature rather than an accidental blockage. Both shafts had been carefully constructed, carefully oriented, and carefully sealed. Whatever their purpose, it was not casual, it was not accidental, it was planned. In 2011, a further robotic investigation was conducted by the JD Project, a collaboration between Egyptian, British, and French researchers. A more sophisticated robot, equipped with a flexible camera that could bend around corners, was sent up the southern shaft to the first blocking stone. The robot drilled a hole through the stone and inserted its camera into the space behind. This time, the camera was able to look not only forward at the second blocking stone, but also backward, at the interior surface of the first stone. What it revealed was unexpected. The interior surface of the first blocking stone had strange red marks, painted or drawn on the limestone, that resembled hieratic script, a cursive form of hieroglyphs used for everyday writing in ancient Egypt. The marks were faint and difficult to read, but their presence implied that the stone had been inscribed before it was placed in the shaft, and that it was therefore not a natural obstruction, but a deliberately placed and marked component of the pyramid's architecture. The JD Project also discovered that the second blocking stone was not solid. It appeared to be thinner and rougher than the first, and the camera detected what seemed to be a small gap or void behind it. But the investigation was halted before this gap could be fully explored. The robot's camera could not reach far enough to see what lay beyond the second stone. The question of what is behind the second blocking stone in the Southern Queen's Chamber shaft remains unanswered. But here's what makes this truly terrifying. These small shafts, only 20 centimeters square, are not the only source of evidence for hidden spaces within the Great Pyramid. The most dramatic evidence came in 2017, when the Scan Pyramids Project, an international collaboration using state-of-the-art muon tomography, announced the detection of a previously unknown large void above the Grand Gallery. The Scan Pyramids project was conceived in 2015 as a collaboration between the Egyptian Ministry of Antiquities and the Heritage Innovation Preservation Institute, under the scientific coordination of the Faculty of Engineering at Cairo University and the French Alternative Energies and Atomic Energy Commission. Its goal was ambitious: use the latest non-invasive imaging technologies to scan the internal structure of the major pyramids at Giza and Dashur, searching for hidden chambers, passages, and architectural features without drilling, cutting, or otherwise disturbing the monuments. The project employed three complementary technologies. The first was infrared thermography, which measures the temperature of the pyramid's outer surface to detect thermal anomalies that might indicate the presence of voids, cavities behind the limestone blocks. Voids and chambers have different thermal properties from solid stone. They heat up and cool down at different rates, producing temperature variations on the surface that can be detected by sensitive infrared cameras. During the winter of 2015, the Scan Pyramids team conducted a comprehensive thermal survey of the Great Pyramid, measuring the temperature of every accessible surface at different times of day. They found several anomalies, including a significant thermal variation on the north face of the pyramid near the base, at a level corresponding to the known entrance and the descending passage. The anomaly suggested the presence of a void or cavity behind the surface blocks at that location. The second technology was muon tomography, a vastly more sophisticated version of the technique that Alvarez had pioneered in the late 1960s. The Scan Pyramids team used 3 different muon detection technologies: nuclear emulsion films, scintillator-based hodoscopes, and gas-filled detectors, developed by teams from Nagoya University in Japan, the French Alternative Energies Commission, and the High Energy Accelerator Research Organization in Japan. These detectors were placed at multiple locations inside and outside the pyramid, collecting muon data over periods of months. The advantage of using 3 different technologies was redundancy. If all 3 independently detected the same anomaly, the confidence in the detection would be very high. The third technology was 3-dimensional reconstruction software that combined the muon data from all 3 detector types, along with the thermal data and detailed architectural surveys, into a comprehensive model of the pyramid's internal structure. The results were published in November of 2017 in the journal Nature, one of the most prestigious scientific publications in the world. The paper, authored by a team of more than 30 researchers from multiple countries, announced the detection of a previously unknown large void in the body of the Great Pyramid. The void was located above the Grand Gallery, roughly at the same height, but offset slightly to one side. It was detected by all 3 muon detection technologies independently, giving the team high confidence in the reality of the detection. The void was estimated to be at least 30 meters long, with a cross-section similar to that of the Grand Gallery, though its precise shape, orientation, and function could not be determined from the muon data alone. The discovery was extraordinary. Here was a void of significant size, comparable to the Grand Gallery, the largest known internal space in the pyramid, located in a region of the structure where no void had been suspected. It was not an extension of any known passage or chamber. It was not connected, so far as anyone could tell, to the known internal architecture. It was a completely new feature, hidden within the mass of the pyramid for nearly 5 millennia, invisible to the eye, but revealed by the ghostly passage of cosmic ray particles through the stone. The scientific rigor of the Scan Pyramids detection deserves emphasis. The void was not detected by a single instrument operated by a single team. It was detected independently by 3 separate detector systems, developed and operated by 3 independent research groups, using 3 fundamentally different muon detection technologies. The Japanese nuclear emulsion films, which record muon tracks as physical traces in a photographic medium, detected the void. The French scintillator-based hodoscopes, which detect muons as flashes of light in crystalline materials, detected the same void in the same location. And the Japanese gas-based detectors, which detect muons as electrical signals in gas-filled chambers, also detected the void. The probability that all 3 systems would independently produce a false positive at the same location is vanishingly small. The void is real. Something is there. The Nature paper reporting the discovery was written with deliberate caution. The researchers were careful to use the word void rather than chamber. They noted that their data could not determine whether the void was a single continuous space or multiple smaller spaces close together. They could not determine its exact shape, whether it was a corridor, a room, a gallery, or an irregular gap. They could not determine whether it had dressed walls and a finished ceiling, like the known chambers, or was simply a rough cavity in the masonry. And they could not determine whether it contained anything. The muon data reveals absence of mass. It cannot distinguish between an empty void and a void containing objects, unless those objects are so massive that they significantly affect the muon absorption rate. The Egyptological response to the Scan Pyramids discovery was mixed. Some scholars greeted it with excitement, seeing it as confirmation that the Great Pyramid still held secrets waiting to be uncovered. Others were more cautious, noting that the muon data, while clearly indicating a region of reduced density, could not distinguish between a single large void, multiple smaller voids, a passage, a chamber, or even a section of less densely packed masonry. The word void, they argued, did not necessarily mean chamber. It could be a construction gap, a space left between courses of blocks during the building process, or a structural feature designed to relieve weight in a critical area of the pyramid. Zahi Hawass, who by this time had left his position as Minister of State for Antiquities but remained influential in Egyptian archaeology, was critical of the announcement. He argued that the Scan Pyramids team had been premature in publishing their findings, that the data was insufficient to draw firm conclusions, and that the term void was misleading because it implied the existence of a chamber when all that had been detected was a region of lower density. Hawass convened a separate committee of Egyptian and international experts to evaluate the findings and recommended further study before any definitive claims were made. But the muon data was clear. All three detection systems, operated by independent teams using different technologies, had detected the same anomaly in the same location. The statistical significance of the detection was high. The paper in Nature had undergone rigorous peer review, and the void, whatever its nature, was real. Something was there, something large, something previously unknown, and something that the existing architectural models of the Great Pyramid could not explain. The debate that followed the Scan Pyramids announcement reveals much about the dynamics of academic knowledge production. On one side were the physicists and engineers who conducted the study. They had applied their technology, obtained their results, and published them in the most rigorous scientific forum available. On the other side were the Egyptologists who felt that the physicists were interpreting archaeological data without sufficient archaeological context. The physicists could detect the void, but interpreting the void, understanding what it meant in the context of Egyptian pyramid construction, required archaeological knowledge that the physicists did not possess, and the Egyptologists, who had that knowledge, were reluctant to accept the implications of data produced by a technology they did not fully understand. This disciplinary tension, physicists detecting what Egyptologists must interpret, has been a recurring theme in the Great Pyramid investigations. The same tension appeared in the Alvarez Muon survey of the 1960s, in the Dormian microgravity measurements of the 1980s, and in the Gantenbrink robot exploration of the 1990s. In each case, the technology revealed something that the conventional archaeological framework could not easily accommodate. And in each case, the response from the Egyptological establishment was caution, skepticism, and a reluctance to revise established models based on data from unfamiliar technologies. Let us now examine the various theories that have been proposed to explain the void, because each one reveals a different understanding of the pyramid and its construction. The first theory is the most conservative. It proposes that the void is a construction gap, a space left between courses of masonry as part of the building process. During the construction of the pyramid, the builders may have used internal ramps, temporary scaffolding, or staged platforms that created voids within the structure as they built upward. When the construction was complete, some of these voids may have been left unfilled, either deliberately or because filling them was unnecessary once the overlying courses were in place. In this interpretation, the void is not a chamber in any meaningful sense. It is an artifact of the construction process, comparable to the gaps between walls in a modern building, present but purposeless. This theory has some appeal. It explains the void without requiring any revision of the standard understanding of the pyramid. It is consistent with what we know about ancient construction techniques, and it does not imply the existence of hidden rooms or undiscovered passages. But it has weaknesses. The void detected by Scan Pyramids is at least 30 meters long, which is very large for a construction gap. Construction gaps tend to be irregular, distributed randomly throughout the structure, and relatively small. A gap 30 meters long and approximately the same cross-section as the Grand Gallery does not fit the profile of an accidental construction artifact. It looks deliberate. It looks planned. It looks like something the builders intended to create. The second theory proposes that the void is a structural feature, specifically a relieving space designed to reduce the weight bearing on the Grand Gallery below. The Grand Gallery is a remarkable engineering achievement, a corbelled corridor 8.5 meters high, spanning a length of 47 meters. The weight of the pyramid above the Grand Gallery is enormous, and the builders would have needed to ensure that this weight was distributed in a way that prevented the gallery from collapsing. One way to do this would be to create a void above the gallery, reducing the weight on its ceiling and distributing the load to the surrounding masonry. This interpretation draws on the precedent of the 5 relieving chambers above the king's chamber, which serve exactly this function. The structural interpretation is plausible, but it raises questions of its own. If the void is a relieving space, why is it so large? The relieving chambers above the king's chamber are relatively low, with flat beam ceilings designed to distribute weight over a specific span. A void 30 meters long, if that is indeed its length, seems excessive for a purely structural function. Moreover, the relieving chambers above the king's chamber are stacked directly above the chamber they protect. The Scan Pyramid's void is above the Grand Gallery but offset, not directly aligned with the gallery's ceiling. This misalignment makes a simple relieving function less likely, though not impossible. The third theory is the most dramatic. It proposes that the void is a previously unknown chamber, a sealed room within the body of the pyramid that was never connected to the known passage system, and that has remained inaccessible since the pyramid's construction. In this interpretation, the void could be anything: a second burial chamber, a storage room for grave goods, a repository for royal documents or religious texts, a symbolic space related to the pyramid's ritual function, or something else entirely, something we have not imagined because we do not yet understand the full purpose of the pyramid. This theory is the one that captures the public imagination. The idea of an undiscovered room inside the Great Pyramid, sealed for 5,000 years, potentially containing the undisturbed burial of Khufu or objects of incalculable historical and cultural value, is irresistible. But it is also the theory with the least direct evidence. The muon data shows a void. It does not show a chamber. It does not show walls, a floor, a ceiling, a sarcophagus, or any other feature that would confirm the presence of a constructed room. The difference between a void and a chamber is the difference between an absence of stone and a presence of architecture. And the muon data, while excellent at detecting the absence of stone, cannot tell us whether that absence is bounded by dressed walls and a finished ceiling, or is simply a gap in the rubble. The fourth theory, proposed by the French architect Jean-Pierre Houdin, is perhaps the most creative. Houdin has spent years developing a comprehensive theory of the Great Pyramid's construction, which he calls the internal ramp theory. Houdin proposes that the builders of the Great Pyramid used an internal spiraling ramp built into the structure of the pyramid itself to transport blocks to the upper levels during construction. The ramp would have spiraled upward around the interior of the pyramid, just beneath the outer surface, with openings at the corners that allowed the blocks to be turned and redirected. After construction was complete, the ramp would have been partially filled in, leaving sections of the ramp as voids within the body of the pyramid. In Houdin's model, the void detected by scan pyramids could be a surviving section of the internal ramp, a passage that was used during construction and then sealed but not completely filled. If correct, this would be an important confirmation of Houdin's construction theory and would provide valuable information about how the pyramid was actually built. But Houdin's theory, while ingenious, remains controversial. Many Egyptologists prefer the external ramp theory, which proposes that the blocks were transported up an external ramp that was later dismantled, or one of several other proposed construction methods. The internal ramp theory has not been definitively proven or disproven, and the scan pyramid's void, while consistent with the theory, does not conclusively confirm it. What makes Houdin's theory particularly relevant to the hidden chambers debate is that it predicts the existence of internal voids as a necessary consequence of the construction method. If the pyramid was built with an internal ramp, sections of that ramp should survive as voids within the masonry. The detection of a void by scan pyramids is exactly what Houdin's theory predicts, and if one section of the ramp survives, others may as well. The pyramid could contain an entire network of former ramp passages, now sealed and hidden, threading their way through the body of the structure in a slow ascending spiral. Such a network would not be a series of hidden chambers in the traditional sense, but it would represent a vast, unexplored internal architecture, a construction highway frozen in stone. Houdin has also proposed a specific explanation for a puzzling feature of the pyramid's exterior. On the northeastern edge of the pyramid, at roughly the height of the king's chamber, there is a notch or indentation in the pyramid's corner that has been visible for centuries but never satisfactorily explained. Houdin argues that this notch marks the location of a turning point in the internal ramp, a corner where the blocks were rotated from one face of the pyramid to the next. If he is correct, the notch provides external physical evidence for the internal ramp's existence and indicates the exact location where the ramp's course can be traced. The subterranean chamber, located beneath the pyramid in the bedrock, presents yet another avenue of investigation. The chamber is rough-hewn, apparently unfinished, with an irregular floor and a mysterious passage extending from its south wall for approximately 16 meters before ending abruptly in a blind face. This passage has never been adequately explained. Where was it going? Why was it abandoned? The conventional explanation is that the passage was part of the original plan for the burial chamber, abandoned when the decision was made to move the burial higher up into the pyramid's body. But if the subterranean chamber was the original burial location, the blind passage may have been intended to lead somewhere specific, perhaps to a subsidiary chamber, a storage room, or a ritual space that was never completed. There is also the curious feature known as the well shaft, a roughly hewn vertical shaft that connects the junction of the ascending passage and the grand gallery to the lower portions of the descending passage, bypassing the granite plug blocks that seal the ascending passage. The well shaft has been interpreted as an escape route, used by the workers who lowered the granite plugs into the ascending passage after the burial to exit the pyramid without being sealed inside. If this interpretation is correct, it implies a remarkable level of planning and a willingness to create hidden passages for purely practical purposes. And it raises the question of whether other such practical passages exist within the pyramid, passages that served temporary construction or ceremonial functions and were then sealed and forgotten. The fifth theory concerns the Queen's chamber shafts and their possible connection to hidden spaces. As we discussed earlier, both the northern and southern shafts of the Queen's chamber terminate in blocking stones. Behind the southern blocking stone, there is a second blocking stone and evidence of a space beyond. What if these shafts are not merely symbolic channels but actual passages, leading to a sealed chamber or chambers deeper within the pyramid? The shafts are too small for a human to enter, but they are large enough to have served as conduits for objects or for ritual purposes. If they lead to a chamber, that chamber could be small but significant, potentially containing objects placed there during the construction as part of the funerary ritual. The difficulty with this theory is that the shafts are too narrow and too tortuous for any existing robot to fully explore. The blocking stones create additional obstacles, and even if a robot could penetrate beyond the second blocking stone, the resolution of its camera might not be sufficient to identify small objects in a dark, dusty space. Nevertheless, the shafts remain one of the most promising avenues for future investigation, precisely because they are the only known features of the pyramid that demonstrably lead to unexplored spaces. The copper fittings on the first blocking stone in the southern shaft deserve special attention. These small metal objects, described variously as handles, pins, or hooks, are unique in Egyptian pyramid architecture. Nothing like them has been found in any other pyramid, any other tomb, or any other ancient Egyptian structure. Their function is completely unknown. They are too small and too corroded to serve any obvious structural purpose. They do not appear to be decorative, since no one was intended to see them in the darkness of a 20-centimeter shaft sealed behind the walls of a chamber. Their very existence is a puzzle. Why would the builders install metal fittings on a stone that no one was ever supposed to see? One possibility is that the copper fittings served a ritual function. In Egyptian funerary belief, certain materials and objects had symbolic significance that went beyond their physical utility. Copper was associated with the afterlife. The hieroglyphic sign for the word eternity, Jed, was sometimes written with a copper determinative. If the blocking stone was intended as a symbolic barrier between the world of the living and the world of the dead, the copper fittings might have served as ritual handles, allowing the spirit of the deceased to open or pass through the barrier on its journey to the afterlife. This interpretation is speculative, but it is consistent with the broader pattern of ritual symbolism in Egyptian funerary architecture. There is a sixth consideration that ties many of these threads together. In 2023, the Scan Pyramids team published an update to their earlier findings. Using refined muon detection data collected over a longer period and with improved detector placement, they were able to refine their estimate of the size and shape of the void above the Grand Gallery. The updated analysis suggested that the void was approximately 9 meters long and roughly 2 meters in cross-section, significantly smaller than the initial estimates but still a substantial space. The researchers also reported that the void appeared to be oriented roughly north-south, parallel to the face of the pyramid, and that its position was consistent with a corridor or passage, rather than a chamber. They proposed that the void might be an access corridor, a passage used during construction to reach the Grand Gallery or the King's Chamber from the north face, which was then sealed and hidden within the masonry. This interpretation, if correct, would be significant for several reasons. An access corridor would imply that the builders had created a passage system that was independent of the known ascending passage and Grand Gallery, a parallel route through the pyramid that was sealed at the completion of construction. The existence of such a passage would demonstrate an even higher level of architectural planning and complexity than previously recognized, and it would raise the question of where the corridor led. If it provided access to the upper chambers during construction, it must have connected to the Grand Gallery or the King's Chamber at some point. Where is that connection? Has it been sealed behind the limestone blocks that line the Grand Gallery's walls? Is it hidden behind one of the massive granite slabs in the King's Chamber? Or does it lead to another space entirely, one that is not connected to any known feature? There is a seventh line of investigation that has received less attention, but that may prove significant in the long term. In 2004, the French architect Gilles Dormion, who had conducted the earlier microgravity surveys, published a detailed study of the Queen's Chamber and its niche. Dormion argued that the niche in the east wall of the Queen's Chamber was not a static feature but a removable panel, and that behind it lay a corridor leading to an undiscovered chamber. He based this argument on detailed measurements of the niche's dimensions, which he found to be consistent with the dimensions of passages elsewhere in the pyramid, and on the observation that the niche's surfaces showed signs of having been cut and modified, possibly to conceal or seal an opening. Dormion's theory was controversial. The Egyptian authorities were skeptical, and many Egyptologists dismissed the idea as speculative. But Dormion persisted. He obtained permission to conduct additional microgravity measurements in the Queen's Chamber, and his surveys detected another density anomaly behind the niche, consistent with a void or cavity in the masonry beyond the chamber's east wall. He argued that this anomaly represented a corridor or passage that had been sealed and plastered over during the pyramid's construction. The Egyptian Supreme Council of Antiquities eventually permitted a limited investigation. A small endoscopic camera was inserted through a drill hole behind the niche. According to Dormion's account, the camera revealed a passage extending into the masonry beyond the Queen's Chamber wall, but the investigation was halted before the passage could be fully documented, and the results were never officially published. The existence of the passage behind the niche remains unconfirmed by independent investigation. An eighth area of inquiry concerns the thermal anomaly detected on the north face of the Great Pyramid during the Scan Pyramids infrared survey in 2015. The anomaly was located near the base of the north face, at a level corresponding roughly to the original entrance. The infrared cameras detected a region of the pyramid's surface that was significantly warmer than the surrounding blocks during the pre-dawn hours, when the pyramid's surface should have been uniformly cool after losing its daytime heat. A warmer surface temperature at dawn suggests that the blocks in that area are either thinner than their neighbours, allowing heat from the pyramid's interior to reach the surface more quickly, or that there is a void behind them that changes the thermal properties of the wall. The thermal anomaly has not been fully investigated. Its significance depends on its cause. If it is produced by a void, the void could be a construction gap, a passage, or a chamber. If it is produced by differences in the thickness or composition of the surface blocks, it might reflect a construction anomaly with no significance for hidden spaces. But the coincidence of the thermal anomaly's location with the general area of the original entrance and the descending passage is suggestive. Is there a hidden passage near the entrance that has not been detected by other means? Could the thermal anomaly mark the location of a concealed corridor that branches off from the known passage system at a point that has not been investigated? The math is striking when we consider the full inventory of anomalies that have been detected within the Great Pyramid. The microgravity anomalies in the Queen's Chamber corridor, the blocking stones in the Queen's Chamber shafts, with their mysterious red marks and their tantalizing second barriers, the thermal anomaly on the north face, the large void above the Grand Gallery, subsequently refined into a possible corridor, the possible passage behind the Queen's Chamber niche, the unfinished subterranean chamber with its mysterious blind passage, the enigmatic niche in the Queen's Chamber wall, the sand-filled cavities behind the corridor walls. Each of these features, individually, might be explained as a structural anomaly, a construction artifact, or an architectural remnant. But taken together, they form a pattern of hidden spaces, a pattern of concealment, a pattern that suggests the pyramid's builders created an internal architecture that was far more complex than what is visible from the known passages and chambers. Let us now consider the broader context in which these discoveries sit. The Great Pyramid is not the only Egyptian pyramid with hidden or problematic chambers. The bent pyramid of Sneferu at Dashur, built a generation before the Great Pyramid, has two known internal chambers connected by a passage system of unusual complexity. A western chamber, accessed from a descending passage on the north face, and an upper chamber, accessed from a separate entrance high on the west face. The two chambers appear to be structurally independent, with no obvious connection between them through the passage system. The presence of two separate entry systems and two apparently independent chambers in a single pyramid is unique, and it has led some researchers to speculate that the bent pyramid, like the Great Pyramid, may contain additional undiscovered spaces. The Red Pyramid of Sneferu, also at Dashur, has three known chambers, two at ground level and one higher up, connected by a corbelled passage that anticipates the Grand Gallery of the Great Pyramid. The Red Pyramid's chambers are relatively well understood, but there are anomalies in the masonry of the upper chamber that have never been fully explained. And in 2019, the Scan Pyramids team conducted muon tomography surveys of the bent pyramid that successfully validated their methodology by detecting the known internal chambers from outside the structure. This validation increased confidence in the team's ability to detect hidden voids and lent credibility to their Great Pyramid findings. The pattern across multiple pyramids suggests that the 4th dynasty builders were willing to create complex internal architectures with multiple chambers, concealed passages, and features that served purposes beyond simple tomb construction. The Great Pyramid, as the largest and most ambitious of all Egyptian pyramids, might reasonably be expected to have the most complex internal architecture of all, and the evidence from Scan Pyramids, Gantenbrink, Dormian, and others suggests that this expectation may be justified. And this is where the answer becomes deeply unsettling, because after more than 2 centuries of investigation, after dozens of surveys and expeditions and technological marvels, we still cannot say with confidence what is inside the Great Pyramid. We have detected voids, we have found blocking stones, we have measured thermal anomalies and gravitational variations. We have sent robots into shafts and particles through stone, and at the end of it all, the pyramid's secrets remain intact. The hidden chambers, if they are chambers, remain hidden. The sealed spaces, if they contain anything, remain sealed. The most studied building on Earth continues to defy our understanding, not because we lack the technology to investigate it, but because we lack the permission, the consensus, and perhaps the courage to follow the evidence wherever it leads. We have now examined the known chambers of the Great Pyramid, the history of their discovery, the technological investigations that have detected anomalies within the pyramid's structure, and the various theories proposed to explain those anomalies. We have walked through the microgravity data, the robotic explorations of the Queen's chamber shafts, the scan pyramid's muon tomography, and the ongoing debate about what the detected voids represent. And what we are left with is something more unsettling than any single discovery. We are left with the recognition that the most thoroughly studied building in the ancient world remains in fundamental ways unknown. Let that sink in. The Great Pyramid has been the subject of scholarly investigation for more than 200 years. It has been measured, mapped, photographed, surveyed, drilled, blasted, probed, scanned, and analysed with every technology that human ingenuity has devised. Hundreds of books have been written about it. Thousands of academic papers have examined its construction, its purpose, its dimensions, its astronomical alignments, its mathematical properties, and its cultural significance. And yet, after all of this effort, after all of these centuries of study, we cannot say with certainty what is inside it. We know what is in the passages and chambers that have been entered. We know, roughly, where the scan pyramid's void is located and approximately how large it is. We know that the Queen's chamber shafts terminate in blocking stones with unexplored spaces beyond, but we do not know what is in the void. We do not know what is behind the blocking stones. We do not know whether there are additional hidden spaces that have not been detected, and we do not know, cannot know, until someone finds a way to look. This not knowing is significant in a way that goes beyond the specific question of what the hidden chambers contain. It speaks to the broader relationship between human knowledge and the physical world. We tend to assume that the things we can see are the things that exist, that the visible is a reliable guide to the real, that if a space has been explored and mapped, it has been understood. But the Great Pyramid demonstrates that this assumption is false. The visible is not all there is. The explored is not all there is. There are things inside this building that no human has seen for nearly 5,000 years, things that exist in the darkness behind sealed stones and above corbelled ceilings and within masses of limestone that weigh millions of tons, and we can detect their presence, but we cannot reach them. We know they are there, or at least we know that something is there, but we cannot say what. And that gap between detecting and understanding, between knowing that and knowing what, is the central mystery of the hidden chambers. The deeper truth of the hidden chambers is that they may hold the key to understanding not just the Great Pyramid, but the entire civilization that built it. The fourth dynasty of ancient Egypt, the dynasty that built the three Great Pyramids at Giza, represents the pinnacle of pyramid construction in Egypt. No subsequent dynasty built pyramids of comparable size, precision, or internal complexity. The 5th and 6th dynasty pyramids are smaller, less precisely constructed, and architecturally simpler. They do, however, contain something the Great Pyramid lacks: texts. The pyramid texts, the oldest known collection of religious writings in Egypt, first appear inscribed on the walls of the burial chamber in the Pyramid of Unas, the last king of the 5th dynasty. These texts, which include spells, prayers, and instructions for the king's journey through the afterlife, provide invaluable insights into the religious beliefs and funeral practices of the Old Kingdom. The Great Pyramid contains no known texts, no inscriptions on its walls, no religious formulae, no spells, no prayers, nothing but the quarry marks found by Weiss in the relieving chambers, which are functional labels, not literary or religious compositions. The absence of texts is puzzling. Why would the most ambitious pyramid of all, the pyramid of the most powerful king of the most powerful dynasty, lack the very feature that was considered essential by later pharaohs? Did Khufu not expect to need magical texts for his afterlife? Were the texts inscribed on materials that have perished, such as wood or papyrus? Or are there inscribed surfaces inside the pyramid that have not yet been found, hidden behind the walls of chambers that remain sealed and inaccessible? This last possibility is particularly tantalizing. If the hidden chambers contain inscribed walls, they could potentially represent the oldest religious texts in Egypt, predating the pyramid texts of Unas by more than a century. Such a discovery would revolutionize our understanding of the development of Egyptian funerary literature and the religious beliefs of the Fourth Dynasty. It would fill a gap in the textual record that has puzzled Egyptologists for generations, and it would confirm what many scholars have suspected but could not prove, that the Great Pyramid was not simply a tomb but a complex ritual structure whose full purpose we have not yet grasped. But there is a darker possibility as well. The hidden chambers may be empty. They may contain nothing but stale air and fine limestone dust, the accumulated detritus of millennia of slow geological processes operating in a sealed environment. They may be construction spaces, structural features, or architectural remnants with no contents of any significance. The void above the Grand Gallery may be exactly what the most conservative interpretations suggests, a gap in the masonry that served a structural function and nothing more. The spaces behind the Queen's Chamber shaft blocking stones may be tiny, irregular cavities with no objects, no inscriptions, no significance beyond their existence as sealed spaces within a massive stone structure. This possibility is worth confronting directly because it illustrates a fundamental principle of scientific investigation. Not every discovery leads to a revelation. Not every sealed space contains a treasure. The hidden chambers of the Great Pyramid may contain answers to some of the most important questions in Egyptology, or they may contain nothing, and we will not know until we find a way to look. The question of how to look is itself a major challenge. The Great Pyramid is a protected UNESCO World Heritage Site. Any invasive investigation, any drilling, cutting, or dismantling of stonework would be fiercely resisted by the Egyptian authorities and by the international archaeological community. The precedent set by Weiss, who used gunpowder to blast his way into the relieving chambers, is not one that anyone wishes to repeat. Modern standards of archaeological practice demand non-invasive or minimally invasive techniques, and the technologies that have been developed for this purpose, muon tomography, microgravity, infrared thermography, ground-penetrating radar, are remarkably capable but ultimately limited. They can detect the presence of voids, they can estimate their approximate size and location, but they cannot tell us what is inside them. For that we need eyes, cameras, physical access, and obtaining physical access to a sealed space within the most famous building on Earth, without damaging the building in the process, is an engineering challenge of extraordinary difficulty. Several proposals have been made. Miniaturized robots, smaller and more flexible than the ones used in the Queen's chamber shafts, could potentially be inserted through boreholes drilled into the masonry. These robots could carry cameras, sensors, and sampling equipment, allowing researchers to photograph, measure, and chemically analyze the contents of a hidden space without opening it to the atmosphere. The technology for such robots exists. The Japanese company Kawasaki, among others, has developed miniaturized inspection robots for use in confined industrial spaces. Adapting such technology for archaeological use would require careful engineering, but it is not technically impossible. Another proposal involves using cosmic ray muon imaging with even higher resolution, combined with neutron tomography or other forms of particle-based imaging, to create a more detailed three-dimensional map of the pyramid's internal structure. Such a map could potentially distinguish between an empty void, a void containing dense objects such as stone or metal, and a void containing less dense objects such as wood or cloth. This would provide information about the contents of the hidden spaces without the need for physical access. A third proposal, perhaps the most ambitious, involves using a specialized drilling system to create a very small, precisely directed borehole from one of the known passages into the detected void, inserting a flexible endoscope or microcamera and photographing the space from within. This approach would require the agreement of the Egyptian authorities, the development of a drilling system capable of operating within the confined spaces of the pyramid's passages, and extreme care to avoid damaging the structure. But it is, in principle, feasible, and it would provide the definitive answer that remote sensing alone cannot. Let that sink in. The technology to explore the hidden chambers of the Great Pyramid exists today. It is not science fiction, it is not a fantasy, it is engineering. The cameras are small enough, the robots are agile enough, the drilling systems are precise enough. The question is not whether we can look inside the hidden chambers. The question is whether we will be permitted to look. And that question is not a scientific question. It is a political one, a cultural one, a question about who has the authority to decide what we are allowed to know about our own past. This is not science fiction. This is a real debate, taking place right now, among real people with real authority, over one of the most important archaeological sites on Earth. And the outcome of that debate will determine whether the hidden chambers of the Great Pyramid remain hidden for another generation, another century, or forever. The deeper truth of the hidden chambers extends beyond the specific question of what they contain. It touches on the way we construct knowledge about the past and the assumptions that shape our understanding of ancient civilizations. The conventional model of the Great Pyramid is fundamentally simple. It is a tomb. It was built to hold the body of Khufu. The chambers served the burial. The passages provided access. The security features deterred robbers. Everything about the pyramid in this model can be explained by reference to a single function, burial. But what if the pyramid had multiple functions? What if it was not merely a tomb but also a temple, a cenotaph, a symbolic representation of the cosmic order, an astronomical observatory, a ritual structure, or something else that we have not yet conceived? The assumption that the pyramid served a single function has shaped every aspect of the investigation. It has determined what questions are asked, what evidence is considered relevant, and what interpretations are deemed acceptable. If we relax this assumption, if we allow for the possibility that the pyramid served purposes beyond burial, then the hidden chambers take on new significance. They are no longer anomalies to be explained away. They are evidence. Evidence of complexity that we have not yet understood. Evidence of functions that we have not yet identified. Evidence of a building that was more than what we have assumed it to be. The ancient Egyptians did not leave us an operating manual for the Great Pyramid. They did not inscribe an explanation of its purpose on its walls. They did not write a detailed description of its interior in any surviving text. Everything we know about the pyramid's function is inferred from its physical features, from analogy with other Egyptian monuments, and from our understanding of Egyptian funerary beliefs and practices. These inferences are educated guesses. Some may be correct, others may be wrong. And the hidden chambers, whatever they contain, represent the places where our guesses might be tested against reality. There is a specific historical example that illustrates how dramatically a single discovery can reshape our understanding. When the tomb of Tutankhamun was found in 1922, the discovery did not merely add one more data point to an already comprehensive picture. It transformed the picture entirely. Objects of types that had never been seen before were found. Technologies of craftsmanship that had not been suspected were revealed. Religious practices that had not been documented were illuminated. The tomb of a single minor king rewrote entire chapters of the textbook on ancient Egyptian civilization. If a minor king's tomb could do that, what could a major king's hidden chamber do? And there is another dimension to this question that is often overlooked. The Great Pyramid was built at a time when the Egyptian state was at the peak of its organizational capacity. The resources dedicated to Khufu's funerary complex were immense, perhaps the largest concentration of labor, materials, and administrative effort in the entire history of the Old Kingdom. The Fourth Dynasty commanded quarries, mines, shipyards, workshops, and administrative centers across the length of Egypt. It could draw on a labor force of tens of thousands. It had access to materials from Aswan to the Delta, from Sinai to the Western Oasis. The idea that such a state with such resources would build a monument of the Great Pyramid's size and complexity merely to house a single empty sarcophagus in a single undecorated room strains credulity. Something more must have been intended, and the hidden chambers, if they exist, may represent that something more. Consider the pyramid texts. the collections of religious spells that appear in later pyramids, beginning with Unas at the end of the 5th dynasty. These texts describe the king's afterlife journey in elaborate detail. They describe the celestial realms through which the king travels. They describe the gods he encounters. They describe the transformations he undergoes. They describe a cosmology of extraordinary complexity and beauty, a vision of the afterlife as a journey through a structured universe with multiple levels, multiple passages, and multiple chambers, each with its own significance and its own dangers. The correspondence between this textual cosmology and the physical architecture of the Great Pyramid has not been lost on scholars. The multiple chambers at different levels, the ascending and descending passages, the grand gallery rising upward like a stairway to heaven, the king's chamber at the summit, the final destination, the celestial realm, the narrow shafts pointing towards specific stars, the portcullis barriers that must be passed. The physical structure of the pyramid echoes, in stone, the textual cosmology of the pyramid texts. And this echo raises a question. Was the pyramid's internal architecture designed to replicate the afterlife journey described in the texts, or rather in the oral traditions that preceded the texts? Were the chambers and passages not merely functional spaces for the burial, but symbolic representations of the cosmic landscape through which the king's spirit would travel? If so, then hidden chambers take on a different meaning entirely. They are not just sealed rooms, they are stations on a journey, stages in a cosmic narrative, spaces that correspond to specific moments or locations in the king's afterlife progression. And their concealment was not merely a security measure, it was a theological statement. The hidden chambers were hidden because the realms they represented were hidden from the living. Only the dead king, making his journey through the afterlife, would enter them. Only the spirit, freed from the body, would pass through the sealed barriers and into the spaces beyond. This interpretation is speculative. It cannot be proven without access to the hidden chambers and knowledge of their contents. But it suggests that the question of what the hidden chambers contain may be less important than the question of what they mean. The physical contents, if any, are secondary to the architectural and cosmological significance of the spaces themselves. The hidden chambers may contain nothing but air and dust, and the faintest traces of 5,000-year-old sealed atmosphere, and they would still be important. They would still transform our understanding of the Great Pyramid, because they would reveal a level of architectural and theological complexity that the conventional model does not accommodate. There is one more dimension of the deeper truth that deserves attention. The question of why we have not already resolved the mystery. The technology exists. The scientific interest exists. The public interest is enormous, and yet the hidden chambers remain unexplored. Why? The answer is not simple. It involves the politics of Egyptian archaeology, the competing claims of national sovereignty and international scholarship, the tension between preservation and investigation, the legacy of colonialism in the study of ancient Egypt, and the very human dynamics of academic turf, personal ambition, and institutional power. The Great Pyramid belongs to Egypt. It is Egypt's most famous monument, Egypt's most valuable cultural asset, and Egypt's to control. Foreign researchers, however well-intentioned, are guests in Egypt's house, and the Egyptian authorities have the right, and perhaps the responsibility, to control access to the pyramid and to determine the pace and scope of investigation. The history of foreign involvement in Egyptian archaeology is not uniformly positive. From Visor's gunpowder to the wholesale removal of antiquities by European collectors in the 19th and early 20th centuries, the record includes instances of damage, exploitation, and disrespect for Egyptian cultural heritage. The sensitivity of the Egyptian authorities to foreign research proposals, particularly proposals that challenge conventional Egyptological narratives, is understandable in this historical context, and the desire to protect the pyramid from well-meaning but potentially damaging investigations is legitimate. But there is a tension between protection and investigation that cannot be resolved by choosing one at the expense of the other. The pyramid is deteriorating. The limestone blocks are weakening under the combined assault of pollution, moisture, temperature fluctuations, and the physical impact of millions of visitors. The iron clamps used in modern restoration work are rusting and expanding within the stone, causing spalling and cracking. The internal chambers are affected by the condensation of moisture from the breath and perspiration of tourists, which deposits salts on the walls and accelerates chemical weathering. Every year that passes without investigation is a year in which the evidence within the hidden chambers, whatever it may be, is potentially degrading. There is also a question of obligation. The Great Pyramid is not just an Egyptian monument, it is a human monument. It was designated a World Heritage Site by UNESCO precisely because it is of outstanding universal value, belonging to all of humanity. The hidden chambers, if they exist, may contain information of extraordinary importance for our understanding of the ancient world. The decision about whether to investigate them should be informed not only by national interest, but by the broader interests of human knowledge and human heritage. But rights and responsibilities must be balanced against the broader interests of human knowledge. The Great Pyramid is not just an Egyptian monument, it is a human monument. It belongs, in a deeper sense, to all of humanity. It represents an achievement of the human species, not just of a single civilization. And the questions it raises about the capabilities of ancient societies, about the nature of human ambition, about the relationship between the living and the dead, are questions that transcend national boundaries. The hidden chambers, if they exist, may contain answers to these questions, and the decision about whether to seek those answers should be informed not only by national interest, but by the broader interests of human understanding. What would it mean if a hidden chamber were found inside the Great Pyramid? And what would it mean if that chamber contained an intact burial? The discovery of Tutankhamun's tomb in 1922 by Howard Carter remains, more than a century later, the most famous archaeological discovery in history. When Carter peered through a small hole in the sealed doorway of the tomb and was asked if he could see anything, his reply, "Wonderful things," has become one of the most quoted phrases in Egyptology. The tomb contained more than 5,000 objects, including a solid gold death mask, 4 nested gilded shrines, a stone sarcophagus containing 3 nested coffins, canopic jars, chariots, thrones, weapons, clothing, food, wine, games, and a vast assortment of personal and ritual objects. The discovery transformed our understanding of the New Kingdom and of ancient Egyptian funerary practices. It filled museums, it rewrote textbooks, it captured the imagination of the entire world. And Tutankhamun was a minor king, a young man who died in his late teens after a reign of roughly 9 years. His tomb, while magnificent, was small by royal standards, likely a hastily adapted private tomb rather than the grand royal sepulchre he would have received had he lived longer. If the burial of a minor king could contain such riches, what might the burial of Khufu, one of the most powerful rulers of the Old Kingdom, the builder of the largest pyramid ever constructed, contain? The answer, if such a burial exists, and if it has survived intact, is almost impossible to overstate. Khufu ruled at the height of Egyptian royal power. His construction projects were the most ambitious in Egyptian history. The resources at his disposal were immense. An intact burial of Khufu would be expected to contain grave goods of a quantity and quality that would dwarf even Tutankhamun's tomb. Royal furniture, gold, jewelry, ceremonial weapons, religious objects, and potentially texts, papyri, inscriptions, or other written records from the 4th dynasty, a period for which our textual evidence is extremely sparse. Such texts could include royal decrees, religious compositions, administrative records, or personal documents that would transform our understanding of the Old Kingdom. The mummy of Khufu itself, if preserved, would be of extraordinary value. No confirmed royal mummy from the 4th dynasty has ever been identified. The mummies of the New Kingdom pharaohs were found in 2 caches in the Valley of the Kings, moved there in antiquity by priests seeking to protect them from tomb robbers. But no Old Kingdom royal mummy has been positively identified. Finding the preserved body of Khufu would provide information about the king's age at death, his health, his diet, his genetic heritage, and the mummification techniques of the 4th dynasty, about which we know very little. but we must be careful with our expectations. The probability that an undisturbed burial of Khufu exists somewhere inside the Great Pyramid is by any honest assessment low. The pyramid has been entered repeatedly over the millennia. Al-Ma'mun's workers broke into it in the 9th century. There may have been earlier intrusions during the Late Period, the Ptolemaic period, or even the Old Kingdom itself. Tomb robbery was pervasive in ancient Egypt, and even the most elaborate security measures were routinely overcome. The granite plugs, the portcullis slabs, the concealed passages, none of these deterred the determined robbers who methodically looted every accessible royal tomb in Egypt over the course of centuries. If there is a hidden chamber, and if it has survived unopened, it would be because it was never connected to the known passage system, never accessible through any passage that a robber could enter. It would have been sealed at the time of construction, buried within the body of the pyramid, and left undisturbed while robbers ransacked the known chambers and carried away everything they could find. The very emptiness of the king's chamber, the complete absence of any contents, might be explained not by the thoroughness of the robbers, but by the simplicity of a decoy. The king's chamber was meant to be found. It was meant to be looted. It was the false prize, the sacrificial offering to greed, while the real burial lay hidden elsewhere, protected not by granite and portcullis, but by the most effective security measure of all: invisibility. This is, of course, speculation. There is no direct evidence that the king's chamber was a decoy. There is no direct evidence that Khufu was buried elsewhere in the pyramid. There is only the empty sarcophagus, the hidden void, the blocking stones in the shafts, and the persistent nagging question that will not go away. Where is Khufu? There is a broader philosophical dimension to the hidden chambers that deserves reflection. The Great Pyramid is the largest and most enduring monument ever built by human hands. It was constructed, according to the conventional understanding, as a tomb, a house for the dead, a vessel for the afterlife, a structure designed to protect and sustain the king's body and spirit for eternity. And yet the body is gone. The spirit, whatever one believes about such things, has departed. The purpose for which the pyramid was built has, by any secular measure, failed. The king is not there. The tomb has been violated. The grave goods have been stolen. The mummy has vanished. And yet the pyramid remains. It has outlasted its purpose. It has outlasted its builder. It has outlasted the civilization that created it. It stands today not as a functioning tomb, but as a monument to human ambition, human skill, and human mortality. It is the most eloquent argument ever made for the proposition that some things endure beyond their purpose, that the act of building can outlast the reason for building, that a structure can survive long after the world in which it was meaningful has ceased to exist. The hidden chambers, if they exist, add another layer to this meditation. They suggest that the pyramid was not merely a monument to be seen, but a structure with secrets, with interior spaces that were never meant to be entered, or at least not by the uninitiated, with a complexity that exceeded what was visible from the outside or from the known passages. The pyramid was not just a tomb, it was a world unto itself, a microcosm containing multiple levels, multiple chambers, multiple passages, connected and disconnected, visible and hidden, open and sealed, a structure that, like the universe itself, contained more than met the eye. The ancient Egyptians believed that the afterlife was not a single destination, but a journey. The dead king did not simply arrive in paradise. He travelled through the underworld, through the sky, through the realms of the gods, undergoing transformations at each stage, passing through gates guarded by divine beings, reciting spells to ensure his safe passage. The pyramid, as the king's vehicle for this journey, may have been designed to replicate this cosmological landscape in stone. Each chamber a station, each passage a route, each sealed barrier a gate, and each hidden space a realm beyond the visible, accessible only to the spirit that had earned the right to enter. If this interpretation is correct, then the hidden chambers are not hiding things. They are being things. They are the afterlife made manifest in architecture. They are the invisible realms of the dead, rendered in limestone and granite, sealed and dark and eternal, as the afterlife itself was believed to be sealed and dark and eternal. They are not waiting to be opened. They are waiting to be understood. There is a parable in all of this about the nature of human knowledge. We build structures to contain what we know. We write books, we construct databases, we develop theories, We create institutions, all designed to hold and organize our understanding of the world. But every structure of knowledge, like every structure of stone, contains hidden spaces. Spaces that we do not know. Spaces that our instruments cannot reach. Spaces that our theories cannot account for. And these hidden spaces are not empty. They contain the things we have not yet discovered, the questions we have not yet asked, the answers we have not yet imagined. We stand at the threshold of a discovery that could reshape our understanding of the ancient world, or we stand at the threshold of another in a long series of tantalizing but ultimately inconclusive investigations that leave the mystery intact and the questions unanswered. We do not know which outcome awaits us. The pyramid does not tell us. It simply stands, as it has stood for nearly 5 millennia, patient, massive, silent, holding its secrets behind walls of limestone and granite that have resisted every attempt to breach them. There is a final philosophical dimension that the hidden chambers demand of us. It concerns the nature of discovery itself and what it means to find something that has been lost for millennia. If a hidden chamber is found inside the Great Pyramid, the moment of discovery will be unlike anything that has happened in archaeology since Carter opened the tomb of Tutankhamun in 1922. The sealed atmosphere inside the chamber, assuming it has remained intact, will be the oldest sealed atmosphere on Earth. The air that the pyramid's builders breathed, the microscopic particles of dust that settled in the still air as the last worker departed and the entrance was sealed, will still be there. 5,000 years of undisturbed silence, preserved in a pocket of ancient atmosphere behind walls of stone. The scientific value of this atmosphere should not be underestimated. Analysis of the gases, the particulate matter, the microbial content, and the humidity of the sealed air could provide information about the environmental conditions inside the pyramid at the time of construction. Pollen grains trapped in the air could identify the plants that were growing on the Giza Plateau nearly 5 millennia ago. Trace chemicals could reveal what materials were present in the chamber when it was sealed. Even the absence of certain gases could tell us something about the conditions of the sealing, whether it was done quickly or slowly, in warm weather or cool, with or without ventilation. The objects in the chamber, if there are objects, would be equally extraordinary. Any organic material, wood, cloth, papyrus, leather, food, would have been preserved in conditions that are in some ways ideal. A sealed stone chamber, dark, dry, and thermally stable, is an excellent preservation environment. Objects that would have decayed in a tomb that was opened and resealed, exposed to moisture and biological activity, might survive intact in a chamber that was never opened at all. The potential for the preservation of organic materials is one of the most exciting aspects of the hidden chamber hypothesis. If wooden furniture, linen wrappings, papyrus scrolls, or other organic objects survived in the sealed chamber, they would be among the oldest intact organic artifacts in the world. And if there are texts, if there are inscriptions on the walls, or papyri in the chamber, the implications would be transformative. The Fourth Dynasty is one of the least well-documented periods of Egyptian history in terms of written records. We have administrative texts, quarry marks, and a handful of brief inscriptions, but nothing comparable to the extensive literary and religious texts that survive from later periods. Texts from a sealed Fourth Dynasty chamber could fill gaps in our knowledge that have persisted for over a century. They could reveal aspects of Fourth Dynasty religion, governance, literature, and daily life that are currently completely unknown. But let us also consider the possibility that the hidden chambers contain nothing, that they are empty spaces, structural features with no contents, voids in the masonry that served a function during construction and nothing more. This outcome, while less dramatic, would still be significant. It would confirm the extraordinary complexity of the pyramid's internal architecture. It would demonstrate that the builders created spaces within the structure that were not intended for human access or for the storage of objects. It would raise questions about the purpose of these empty spaces and the architectural thinking that produced them, and it would close certain lines of speculation while opening others. Either way, whether the hidden chambers contain wonders or emptiness, the act of looking inside them would be a milestone in the history of human inquiry. It would represent the culmination of a quest that began when Weiss lit his first fuse in 1837, and that has continued through every subsequent investigation, every robotic probe, every muon scan, every microgravity measurement to the present day. It would be the moment when the most patient of all human buildings finally yields its deepest secrets, or the moment when it reveals that some secrets are not secrets at all, but simply spaces, empty and silent and meaningless, waiting to be filled with our interpretations and our hopes. And yet even that answer, even the answer of emptiness, would be a kind of gift, because it would close a question that has been open for centuries. It would end the speculation. It would replace hypothesis with observation, theory with fact, imagination with reality. And it would free us at last to see the Great Pyramid not as a repository of projected fantasies, but as what it actually is. A building, an extraordinary, unprecedented, unparalleled building, built by human hands for human purposes, containing human ambitions and human fears and human hopes sealed within its stones. The hidden chambers are not the mystery, they are the test of whether we have the patience, the wisdom, and the courage to find out what is actually there rather than what we wish were there. The test of whether we can face the past on its own terms rather than ours. The Great Pyramid of Giza has been standing for nearly 5,000 years. In that time, it has been a tomb, a treasure house, a quarry, a tourist attraction, a symbol, a mystery, and a challenge. It has been climbed, tunneled, blasted, drilled, scanned, and scrutinized by every generation that has encountered it, and yet it has given up only a fraction of its secrets. The known chambers, impressive as they are, may represent only a portion of the pyramid's internal architecture. The hidden spaces, detected by instruments but untouched by human hands, wait in the darkness for someone to find a way in. We do not know what the hidden chambers contain. We may never know. The political, cultural, and practical obstacles to investigation are formidable, and they show no signs of diminishing. The Egyptian authorities, understandably protective of their greatest national treasure, have been reluctant to permit the kind of invasive investigation that would be needed to access the detected voids. The international archaeological community, still haunted by the damage done by Weiss and other early explorers, insists on non-invasive methods that may never provide the definitive answers that only direct observation can supply. And the pyramid itself, massive and implacable, offers no assistance. It does not want to be understood, it wants to be endured. But the technologies continue to improve. Muon detectors become more sensitive, robots become smaller and more capable. Imaging systems achieve higher resolution, and with each improvement, the picture of the pyramid's interior becomes slightly clearer, slightly more detailed, slightly closer to the point where the hidden spaces can be identified, characterized, and perhaps explored. The day may come in our lifetime or in our children's, when a tiny camera, inserted through a borehole no wider than a finger, peers into a space that no human eye has seen since the reign of Khufu. What it shows, whether wonders or emptiness, will be one of the defining moments in the history of archaeology. The Great Pyramid was built to last, and it has lasted far beyond any reasonable expectation, far beyond the survival of the civilization that created it, far beyond the memory of the king for whom it was built. It has lasted through the rise and fall of empires, through the birth and death of religions, through revolutions in technology and transformations in the understanding of the natural world. It has lasted because it was built of stone, and stone endures. And within that stone, in the spaces where the muons reveal the absence of mass, and the infrared cameras detect the ghost of temperature difference, there may be chambers that have lasted too. Chambers that were sealed and hidden and forgotten, chambers that have waited in the darkness while the centuries passed, while the sand rose and fell around the pyramid's base, while the casing stones were stripped and the apex was lost, and the world outside changed beyond all recognition. Those chambers, if they exist, are the most patient things in the world. They have been waiting for nearly 5,000 years. They can wait a little longer, but every year that passes, every decade that slips by without investigation, is a year and a decade in which the questions grow no closer to being answered. The technology is ready, the knowledge is available, the will is lacking, and the pyramid stands, as it has always stood, massive and silent and full of spaces that no one has ever entered. Think of what those spaces have witnessed in their silence and their darkness. They were sealed when Egypt was young, when the pharaohs still ruled from Memphis, when the pyramids were new and their limestone casing gleamed white in the desert sun. They were sealed when the world outside knew nothing of Greece, nothing of Rome, nothing of the civilizations that would rise and fall and rise again across the millennia. They were silent when Alexander came to Egypt. They were silent when Caesar stood beneath the pyramid. They were silent when the Arabs built Cairo. They were silent through the Crusades, the Renaissance, the Industrial Revolution, the World Wars, the Space Age, the Digital Age. Through it all, the hidden spaces have endured in their perfect darkness, unchanged, unvisited, undisturbed, holding whatever they hold with the patience of stone. And they are still there, right now, as you listen to these words, behind walls of limestone and granite, above the Grand Gallery, beyond the blocking stones in the Queen's chamber shafts, in spaces we have detected but cannot reach. The air in those spaces, if they are truly sealed, has not been breathed since the 26th century before the Common Era. The darkness in those spaces has not been broken by light since the builders sealed the entrance and walked away. The silence in those spaces has not been disturbed by a human voice since before the alphabet was invented. We began with a question. What lies hidden inside the Great Pyramid? We end with the same question, unanswered but enriched by everything we have learned along the way. The known chambers tell a story of extraordinary ambition and engineering skill. The hidden spaces tell a story of secrecy and concealment, and the gap between what we know and what we suspect tells a story about the limits of human knowledge, the stubbornness of stone, and the enduring power of a question that refuses to be answered. There is something deeply human about the pyramid's silence. We have all kept secrets. We have all sealed things away, behind doors and walls and locked drawers, hoping that they would remain undisturbed. The impulse to hide is as old as the impulse to build, and the Great Pyramid, the greatest building of the ancient world, may also be the greatest hiding place. A structure designed not only to be seen but to conceal, not only to impress but to protect, not only to endure but to keep its secrets through the full span of human history, from the age of the pharaohs to the age of the particle detector, from the dawn of civilization to whatever comes next. The Great Pyramid is not a simple building. It is a puzzle, a challenge, a monument to the idea that some things are worth hiding and some things are worth finding. It is a structure that was built to protect its contents from the passage of time and the depredations of the curious. And in this at least, it has succeeded. Whatever is inside those hidden chambers, it is still there, still waiting, still protected by millions of tons of limestone and granite, by the weight of 5 millennia of accumulated silence, and by the simple, unanswerable question that the pyramid poses to everyone who stands before it. What is inside? What did they hide? And will we ever know? The muons continue to rain down from the upper atmosphere, passing through the pyramid as they have passed through it for all of its existence, recording the density of every block, the shape of every void, the outline of every hidden space, in the ghostly language of subatomic physics. The thermal cameras continue to watch the pyramid's surface through the desert night, measuring the temperature of every stone, searching for the telltale warmth that betrays a hollow space behind a solid face. The robots wait in their workshops, their cameras and their treads, and their flexible arms, ready for the day when they will be sent back into the darkness of the shafts, past the blocking stones with their copper fittings and their red-painted marks, into the unknown spaces beyond. The technologies are ready, the scientists are ready, the world is ready. Only the permission is lacking, only the political will, only the decision by the people who have the authority to make it, to allow the investigation to proceed, to let the cameras see what the muons have already detected, to let the robots go where the particles have already gone, to let the silence of 5,000 years be broken, gently, carefully, respectfully, by the soft whir of a camera motor and the faint click of a shutter, recording for the first time what lies behind the stones that the builders sealed when the world was young. Perhaps the next generation of technology will make the question moot. Perhaps muon detectors will become so sensitive that they can image the contents of the hidden spaces in detail, sufficient to identify individual objects. Perhaps neutron tomography or some other particle-based imaging technique will allow researchers to determine whether the voids contain dense materials, organic remains, or empty air without ever breaching the pyramid's walls. Perhaps the answer will come not from inside the pyramid but from outside. From a new discovery at another site, a papyrus found in a desert cave, an inscription discovered on a quarry wall that reveals what the builders intended when they sealed those final chambers and walked away into the Egyptian sun. Or perhaps the answer will come in the simplest possible way. A small borehole, a flexible camera, a screen glowing in the darkness of a research tent on the Giza Plateau, and on that screen an image that no human has seen for nearly 5,000 years. A room, a space, a place that was sealed when the pyramids were new and the pharaohs ruled and the world was young. What will the image show? Stone walls, smooth or rough? A floor, empty or furnished? Shadows concealing or revealing? We do not know. We cannot know. Not until someone looks. The stones do not answer. The darkness does not yield. And the pyramid, the oldest and greatest of human constructions, keeps its counsel as it has kept it since the day the last block was placed, and the last worker descended the courses, and the silence began. A silence that has lasted for nearly 50 centuries. A silence that holds within it the possibility of revelation, the promise of answers, the weight of all the questions that have ever been asked about this extraordinary, impossible, patient building. A silence that for now endures,